Hi everybody, this is Mr. Short. We're going to take a look at one example of writing an electron configuration. If you scroll down towards the bottom of the page, you'll find the example of potassium. Now before we get to that, this is the order of electron configuration right here. And remember, it's not something that you're going to have to memorize. It's always going to be given to you. You just need to know what to do with it. So as far as what we do with this, remember you always have to work from left to right and fill up any of those previous sublevels before spilling any electrons over to the right to subsequent sublevels. And each sublevel can hold this number of electrons respectively. S can hold 2 electrons, P can hold 6 electrons, D can hold 10 electrons, and F can hold 14 electrons. Now again, let's take a look at the example of potassium. Potassium is element 19, and that means that it has 19 protons, but it also means that it has 19 electrons. Okay? The reason that it has the same number of protons as electrons is because we have standard format right here, and it does not have a charge in the upper right-hand corner. So we want to represent all 19 of those electrons. Now remember, when you write an electron configuration, the exponents, or the superscripts, are the electrons. So we need the sum of those exponents to add up to 19. Okay, here's how we write the electron configuration for potassium. We always start on the left, so it's going to be 1s. I have to do this quite a bit right here, and it's going to be 1s2. Next is going to be 2s, and we have to fill that up completely. So that's going to be 2s2. Next after 2s is 2p. P is a sublevel, a bucket that can hold 6 electrons, so it's going to be 2p6. Next after 2p is 3s. See how we always have to follow that order. This is going to be 3s2. Next after 3s is 3p. So it's going to be 3p6. And finally, if we take a second and add these exponents up, see how these exponents right here add up to 10. The first chunk of 3 pieces of information always adds up to 10. So we've got 10 plus 2 is 12. Plus 6 is 18. So now we just need one remaining electron. That one remaining electron is going to go in the 4s energy level and sublevel. It's going to be 4s1. Now a lot of students will struggle with this. They'll want to put 4s2 because s is a sublevel that can hold 2 electrons. But think about it. If you have a bucket for holding water and it's a 2-gallon bucket, your 2-gallon bucket could hold either 2 gallons, 1 gallon, or 0 gallons, but it can't hold 3 gallons, right? So for that reason, it's perfectly fine that this is 4s1. And now if we take a look, the sum of the exponents is going to add up to 19 electrons. 2, 2, and 6 is 10. There's 12, 18, 19. So that's how you write the complete electron configuration for potassium. Thanks a lot, guys. See you soon.